Back, Naji here. So we are continuing a discussion with Langchain retrievers, and in this video we'll be discussing on ensemble retrievers. So you may have heard about ensemble machine learning models, right? In which we'll be using multiple machine learning models, and we may combine the result from these machine learning models to finalize the final result, right? Similar to that, we will have an ensemble retrievers in which we'll be combining multiple retrievers together, and we will take advantage of both these retrievers. So we will have a ensemble packet, ensemble class will be there, and we have to initialize it with the multiple retrievers, okay, and we will able to retrieve the better results or better documents based on that. So for example, the common pattern or common use case is, you may have been heard about the BM25, okay, which is a sparse retriever, and we have our FAISS or chroma retrievers, which is a embedding or the dense retrievers. So the sparse retriever means which will retrieve based on the keyword search. So BM25 is retrieving the based on keyword search, which means that if we give a keyword, it will actually trying to get the document which matches with this keyword. It will not look for the semantic similarity. For example, if we ask about AI, or if you search about machine learning, okay, it will just check for the keyword machine learning, and it will return the document which matches with the machine learning. If somewhere in the document, if it is mentioned, if a chunk mentioned about the ML, the BM retriever will not able to identify the ML means it's a machine learning, right? But when we consider about the dense retrievers, retrievers like chroma retrievers or the FAISS retrievers, okay, it will actually retrieve based on the cosine similarity, okay. But what happens is that sometimes if we don't have what we call the much of context, or the query is very small and context is too big, sometimes the dense retrievers may not able to retrieve the exact details from by using the similarity search. But instead of when we talk about the BM retrievers, which will only retrieve based on this keyword search. So if the query is too small, maybe sparse retrievers may give the better result. But if the query is if the context is very clear, then dense retrievers may give the better result. So ensemble retrievers, we will able to combine these two retrievers, and we will able to get benefit from both these retrievers. So we'll see how that can be done. So let me go to the Visual Studio Code. Here I have few documents are there. Okay, so it's actually says Python is a versatile programming language used for web development, data science, and artificial intelligence. And we have the few corpuses there. So what I am going to do there, I am going to search for this. Okay, the query is AI in healthcare and web development. Okay, so we'll see how can we implement this using ensemble retriever. For that, what you guys have to do, first you guys have to install the requirement.txt file. Within the requirement.txt file, we have to run rank_BM25, which is needed to run the BM25 retriever. Okay, now what we can do some import. We can have a Langchain.retrievers. We can import ensemble retriever. Then from the Langchain, community.retriever, we can import BM25 retriever. Okay, and I can have a from Langchain community.vector store, we can import FAISS retriever. FAISS vector store, and here let me check Langchain. Can use Olama. We can import Olama embeddings. Okay. So we have our documents are there. We have our query and we have our import. And first we can install we can try to retrieve from the BM25 retriever. So same way, BM retriever dot from text. I am going to give the corpus here. this is the corpus, and we have a metadata information. So this is the metadata that I am going to use. I am going to give the source, source maybe I can say BM, just give BM25, we'll see, and this has to be like length of corpus. So this is my metadata. Let me see what it says. This has to be something like this. Okay. So here we have initialized the BM25 retrievers. So this is the metadata. So what this means is we will be, so this corpus has a size of maybe, let me check the size. I can check the 7. So what happens that we will be creating 7 dictionaries like this, and which will be appended with this metadata information as this corpus. Okay, so that is why we are just multiplying with this length of corpus. Now what we can do, I can check BM25 retriever dot k. We'll say that we will be retrieving the 2 documents. Now here we can have an invoke method. We'll see. We can pass the query. So this is the query, and the query is retrieving 2 documents. One is the web development often involves Python programming and HTML, CSS, JavaScript, and it says BM25 is a keyword-based retrieval information system. So these are the 2 documents that is retrieved from the BM25 retriever. Now we'll see how can we use the FAISS retriever, which is we already discussed about this. For that, what I can do, I can create an embedding, and this time we will be using the Olama embedding from PHI 3. This is a Microsoft. Okay, so this should be model name, I believe. Okay, so this is from the Microsoft. Now we can have a FAISS vector store. What I can do, I can have a FAISS from text. Here we can pass the text as corpus, and I can pass embedding as embedding. Now we can have a metadata similar to what we have done earlier. Here I can pass source equal to PM, sorry, not PM, I can have FAISS, and this will be repeated for all the, based on the all the corpus. So it says, okay, the same mistake I have made. Let me, okay, so now we have our FAISS vector store is there. Now what we can do, we can have a FAISS retriever. FAISS retriever can be FAISS vector store dot as retriever, and here we can pass the search keyword, search argument, search keyword args, and I'm going to set k is equal to 2 here. Here I can have a FAISS retriever dot invoke. I can pass the query. We'll see the result. Okay, so it says about the healthcare industry benefit from AI, robotic and machine learning, and BM25 is used for the keyword retrieval information system. So these are the 2 documents that is retrieved from the FAISS retriever. Now we'll see how can we combine these 2 retrievers. For that we'll be using EnsembleRetriever. I can use the EnsembleRetriever, and EnsembleRetriever, here we can mention about the base retriever. Okay, so here we have a retrievers. I can pass the base retriever, that is one is BM25 retriever and other one is FAISS retriever. Okay, now I can pass the weight, how much weight this has to be given. So this will be, I can pay 50% for BM retriever, and I can have a 50% for the FAISS retriever. And here we can have a docs, I can have a documents, I can have a ensemble retriever. Okay, I made it wrong. Let me make it ensemble retriever dot invoke. Sorry. Okay. Now we have combined result from these two result, BM25 and the FAISS. It has a BM25 used for the keyword search retrieval information system. The web development often involves Python alongside HTML, CSS and JavaScript. And the third one is the healthcare industry benefit from AI, robotics and machine learning. Okay, so if you look on these two, the result is result from FAISS is 2, like the healthcare industry benefit from AI. Here we can see the healthcare industry benefit from AI is there, and BM25 used for the keyword based search and BM25 used for keyword search. And these two, the BM25 used for keyword search will be there. I mean, it's there in both retrievers, BM25 and the FAISS retriever. So it's coming as the first in the ensemble retriever. And we can see the second one, web development often involves Python alongside HTML and CSS. That here we can see that is with the BM25 retriever. Okay, so in this way it will combine the result of both of these, the bias, BM25 and the FAISS retrievers, and will giving the more quality context. So this can be passed to the LLM model, then LLM model will be able to generate accurate result. So that's it. So please try to do practice with this notebook, so we'll give more understanding. Okay, so please do like and subscribe. Have a nice day. Bye bye.